Okay, so we're going to do one board work type problem here. After you watched that part of the lecture on how to calculate this surface integral over S of f dotted with n hat ds. I want you to calculate that for this force, right? 0, comma 2y, comma 3z. And I want you to do the surface, f of xy equals 3x plus 2. So it's really just a plane, right? That is above the cylinder, x squared plus y squared plus 4. You could also say like this is what the equation of the shadow would be in the xy plane. So x squared plus y squared plus 4. So go ahead, give it a shot, and I will walk through the whole thing in a moment, but I'd like you to hit pause and see if you can follow the structure of that lecture and complete this problem. It's pretty similar. Okay, here comes my solution. The answer is 24 pi, I think. Yep. Okay, so I'll just go through real quickly. So if you want to check a small error, you can. And then I'll go and I'll walk through all the parts. Okay. All right, so first thing I'm going to do is find n hat ds. Remember, n hat ds is minus f sub x minus f sub y, comma 1 times dx dy. So the thing that I'm going to take the partials of is the surface, which is this 3x plus 2. So the partial x is 3, so I get a negative 3 from this negative sign. There's no y component, so the partial y is 0. That's really convenient. And then the partial z, or sorry, and then I get the 1 here goes right there. So that's my n hat ds. My region, which I sort of alluded to, is a circle of radius 2 in the xy plane. That would be the shadow of this surface, right? It's kind of defined by this thing, which tells me that I'm probably going to use polar, but I'm going to wait to do that conversion. So next I am going to actually dot these two, right? So I'm going to do the double integral over S of f, which is this f, dotted with n hat ds. I'm not going to try and figure out what n hat is. I'm just going to use this n hat ds from here, right? So I'm going to dot this guy with this thing, which gives me 0, 2y, 3z, dotted with negative 3, 0, 1, dx dy. My region is that circle that we talked about. So I'm definitely going to flip over to polar now. So I'm going to go integral from 0 to 2 pi, and then integral from 0 to 2. I'm going to do my dot product multiplication before I sub any polar conversions in, but I am going to convert the dx dy into r dr d theta right there. So this is really convenient again. The 0 times this makes that go away. The 2y times the 0 makes this go away. So I'm just left with 3z times 1. So that 3z here shows up there. Then I'm going to use z equals f of x comma y, right? This might be this could be a spot where you would get stuck if you're like, if you haven't practiced this a bunch, right? But it's like, how do we do the integral of 3z? Well, remember, this is the z that we are on when we're on this surface, 3x plus 2. So I can replace that z with 3x plus 2. So I'm using z equals f of x comma y, which is 3x plus 2. And then I'm not going to leave it like that because we're working in polar clearly here. So I'm going to go 3r cosine theta plus 2. I replace the x with the r cosine theta. So from there, I'm going to simplify all the algebra on the inside of my integral. This gives me 3r squared. Don't forget the r and the r dr d theta, right? So I get 9r squared cosine theta. And then this multiplies by that to give me 6r, and then dr d theta. I'm going to integrate from 0 to 2 on the r's first. Power rule here gives me 3r cubed um, plus 3r squared. And then there's the cosine theta here on that r cubed because it just comes along for the ride. Evaluating from r equals 0 to 2, it's convenient because the 0 goes away. So I really just have to plug in the 2's. That gives me 24 cosine theta plus 12 sorry, the integral from 0 to 2 pi of 24 cosine theta plus 12 d theta. And then the cosine integrates to a positive sign with a 24. The 12 goes to a 12 theta, and I'm integrating from 0 to 2 pi. Since we have a sine and we're going 0 to 2 pi, that's really convenient again. Those guys zero out. So I really just have to do 12 times 2 pi, which gives me 24 pi. So hopefully you're okay with that. What would this be? Imagine a cylinder, or imagine a like the xy plane, looking down at that x here, y here, and then this surface up above it that is this thing. It would be the flux of this force, this vector field here, out of that surface uh, in this, where this would be the shadow of that space right there. So hopefully you're okay with this. I'm only asking you to do like simple problems like this, and we will move on Monday. So thank you.